Hello ladies and gentlemen, welcome back. This video tutorial is for students who are in Geometry Chapter 4 on the software. This is a soft introduction. First, we need to build yourselves up and get you used to what similar polygons are like, how scale and dilation affects everything before we get into the real meat of the chapter, which is very basic fundamental trig. But first things first, let's talk about similar polygons and get us used to what's in store for us. So, scrolling down. We're going to start with some pretty basic stuff first. They kind of want to, can I get it all on one screen? They kind of want to get you used to how similar figures actually have a little bit of a benefit to you. So, for example, we see the measure of angle A is 40 degrees and the measure of angle B is 70 degrees. In the triangle DEF, we know that angle D is 40 and then the measure of angle E is also 7D. So that means that these two triangles are similar. We'll get into the how we can prove that later. Based on this, what is the measure of angle C? Question mark, question mark. What that means is all angles in a triangle add up to the famous number in geometry, 180. So you're doing 180 minus 4t minus 7d, which is basically 180 minus 110, which means the measure of angle C is 70 degrees, and we're doing the exact same math for angle F, which means it is also 70 degrees. So use the ruler. Again, this is one of the ones where you have one of those manipulatives in the software where you come in and they actually give you a ruler and then you have to measure it out. I don't have that ability here, so I'm going to make up some numbers just for the sake of argument. So we're going to say 4 and 4, and eeny, meeny, miny, mo, we'll call this 5. So AB is 4, DE is going to be, oh, that's right, I need numbers for this. We'll say 2, 2, and 2.5. So AB is 4, DE is going to be 2, BC is 5, EF is 2.5, CA is 4, and then DF is 2. So when you do the fractions out, you're going to get the same number every time, which in this case is 2. And then what are you actually picking? The angles of each pair, statements below. For each pair, select a true statement. The angles of triangle ABC have the same measures as the angle of DEF. Yes, yes they do. The ratios corresponding to the side lengths are equal to each other. Yes, yes they are. The triangles are similar. Yes. So this is what they mean by similar. And similar, by the way, is just the squiggle. If congruent is the squiggle with an equal symbol, similar is just the squiggle. What that means is it is the same shape, but not necessarily the same size. They have different sizes. That's what similar means. So over here, now we're going to do the same thing again. So let's see here. A is 30, which means D is 30. Let's see here. B is 56, which means E is 56. How do we find the missing angle measure? 180 minus 30 minus 56, which means 180 minus 86, which is going to be 94. 94 and 94. Okay, now let's make up some different angles. Let's see here. Let's do 3, 4, 5, and then we'll do 9, 12, and 15. You can kind of tell if you can see them, track the numbers, what I'm doing. AB is going to be 5 and DE is 15. BC is 3 to 9. CA is 4 to 12. And what is the ratios? 0.33, 0.33, oh no, the simplest form, so we can leave it as a fraction. Oh, thank goodness. So it's going to be 1/3, 1/3, 1/3. So are the angles the same measure? Yes. Ratios are equal? Yes. Triangles are similar? Yes. And you start to realize that this section of the problem is exactly the same, which is the point. Now, similar polygons, same idea. Now that we know it's the same shape and different size, now we can do a setup. So find the length x of st. So this corresponds, what's the matching side over here? This. So it's going to be x over 2. What I like to do, because you see how they kind of give us some decimals, I'm not a fan of that. I'm going to pick a whole number, 7, and what's its corresponding side? 5. There's my ratio, and now I just cross multiply and solve. Keep note, you want to keep everything matching. So this was on the bigger figure, which means the number over here has to be from the bigger figure. 2 is from the smaller figure, so you want to pull it from the smaller figure here, just in case you forgot that from back in the day when you were doing proportions. So that's going to be 5x equals 2 times 7 is 14. Divide by 5, divide by 5. This at least, well, it doesn't divide evenly. It will be 2.8, and that's going to be your answer. Over here, we want to find x, which corresponds to 4. So x over 4, that's going to be small over big. Let's see here. What are some real big, decent numbers? None of them work. Okay, so we'll do 0.5, 0.5 over 1. So x equals, 2. Hey, we got lucky. Nice. All right, so that deals with similar polygons, pretty basic, straightforward math. Similar right triangles. Now we start getting to some fun stuff. Okay, find the length of x. So again, the same kind of idea. You always want to have something basic, so like small over big, or maybe big over small. Like I'm not going to care because you're going to get the same number. So small over big. So x over 3, small over big. 5 over 6. There's our proportion. Cross multiply, so 6x equals 15. X equals 15 over 6, which simplifies to 5 over 3. I assume they're going to want it as a fraction. If not as a decimal, that is going to be 1.6 repeating, so 1.67. Let's see here, small over big, so x over 9 equals, now this is a trick question. Be careful when you see this one. X corresponds to 9. 3.5 is my small, 3.5. But if I'm looking at my big, that's the entire length. A lot of kids make the mistake of just putting in the 7. No, 7 is only from here to here. It's not the entire side. So what is 3.5 plus 7? 10.5. All right, Ms. Dubois, do your decimals. So 10.5x equals 27, 31.5, I think. Let's double check with a calculator. 9 times, what was it? 3.5. 3.5. Yes. Okay, and now if we divide by 10.5, what do we get? 3. Oh, good, we got lucky. So x equals 3. Okay, so far so good. We're looking pretty confident now. And now we wrap up. Let's see here. Determining if figures are related by similarity transformations. So again, because I don't have the ability to screen grab the interactivity, you're taking this shape, moving it around however you want in order to make it fit this. If it works, great. If not, you just write, or rather I should say click the button not possible. Next up, exploring in terms of similarity transformations. Similarity transformations, well, this is what it explains. So we have our two triangles. We can kind of see that they're similar, and you can kind of see that we're going to be moving one over in order to make it match. Then FE to JK. So FE is 12 to JK, which is 16. That simplifies to 3/4. EG is 27 to 36. Those are both divisible by 9, which is conveniently, oh look, 3/4. FG is, oops, I did that wrong. Let me move that over because I just moved this to the wrong spot. This goes over here. Silly Miss Dubois. And now what is going to be the actual EG? EG is 24 over 32. Those are both divisible by 8, which means this is 3/4. Oh, look, they're the same fraction. It's almost like we've been learning that over the course of this entire video. And then again, same as we are with congruent triangles, this is basically a matching game. And if you're trying to match up, you're trying to get your, here's your vocab word, you want to get your corresponding angles. So J corresponds to what? Angle F. Angle K corresponds to what? Angle E. Angle L corresponds to what? Angle G. And are they similar? Yes, they are. If for some reason I don't think it happens on this particular topic, but if you got different ratios across the three of these, then the two would not be similar. All right, that's all the basics for similar polygons. Now that we understand how similar polygons work, we're going to talk about scale and dilation in the next video. As always, stay happy, stay healthy, stay safe. I'll see you in the next one.